Module 2, Networks and Decision Mathematics. In question 1, we are asked to calculate the sum of the degrees of the vertices in the graph shown above. The degree of a vertex is given by the number of edges connected to it. This vertex, for example, has degree 3 because there are 3 edges connected to it. So this graph has 2 vertices of degree 3 and 3 vertices of degree 2. Therefore, the sum is equal to 2 times 3 plus 3 times 2, which is 12. So the answer we are after is option E. From the 2019 VCE examination report, 85% of the students chose the correct option. In question 2, we are asked to determine the minimum number of extra edges that are required so that an Eulerian circuit is possible in the graph given above. For an Eulerian circuit, the graph must have all vertices of even degree. This graph has 4 vertices of odd degree. Therefore, we need at least 2 edges to make these 4 vertices of even degree. So the answer we are after is option C. From the 2019 VCE examination report, 64% of the students chose the correct option. Question 3. The flow of water through a series of pipes is shown in the network below. The numbers on the edges show the maximum flow through each pipe in liters per minute. The question is asking for the capacity of cut Q in liters per minute. We need to determine the capacity of the edges going into the cut Q from left to right. So the capacity of cut Q is equal to 5 plus 6 plus 3, which is 14 liters per minute. Therefore, the answer we're after is option C. From the 2019 VCE examination report, 85% of the students chose the correct option. Question 4. 2 graphs labeled Graph 1 and Graph 2 are shown below. The question is asking which one of the following statements is not true. Option A is definitely not true because isomorphic graphs have the same number of vertices and the same number of edges. From the 2019 VCE examination report, 71% of the students chose the correct option. Question 5. The following diagram shows the distances in meters along a series of cables connecting a main server to 7 points, A to G, in a computer network. The question is asking for the minimum length of cable in meters required to ensure that each of the 7 points is connected to the main server directly or via another point. In other words, we are looking for the minimum spanning tree. We are going to start with the edge with the smallest length, that is from the main server to D, that is 15. We are now going to look for the edges with the next smaller length, that is 28, so from D to E and from A to B. We are going to continue in this manner until all the points are connected. The length of the minimum spanning tree then is 15 plus 2 times 28 plus 30 plus 32 plus 2 times 35, which is equal to 203 meters. So the answer we are after is option B. From the 2019 VCE examination report, 75% of the students chose the correct option. Question 6. The map below shows all the road connections between 5 towns, P, Q, R, S, and T. The question is asking for the adjacency matrix for these road connections. First of all, notice that there is a loop at P. Therefore, we need to have a 1 in row 1, column 1. This will cross out options C and D. Between Q and P, there are 3 different road connections. The only answer that has 3 in row 1 and column 2 is option A. From the 2019 VCE examination report, only 39% of the students chose the correct option. Question 7. A project involves 9 activities from A to I. The immediate predecessor of each activity is shown in the table below. A direct network for this project will require a dummy activity. The dummy activity will be drawn from the end of, so let's draw a diagram. From the start, we have activity A, which has no immediate predecessors, and then we have activities B and C that have A as an immediate predecessor. Activity D has activity B as an immediate predecessor. Activity E has both B and C as immediate predecessors. Therefore, we are going to need a dummy activity from B to E. So the answer we are after is option B. From the 2019 VCE examination report, 42% of the students chose the correct option. Question 8. The directed network below shows the sequence of activities A to S that is required to complete a manufacturing process. The time taken to complete each activity in hours is shown. The question is asking for the number of activities that have a float time of 10 hours. Let's start by determining the earliest starting times for each activity. For the earliest starting times for the activities M and K, we need to choose the highest number between the activities J and F. Therefore, it's going to be 18. For activity L, we need to choose the highest number from activities G and H, and that is 16. For activity O, we also need the highest number coming from activities K and L, which is 24. For activities P and Q, we need the highest number between 21, 23 and 31, that is 31. And for activity S, we need again the highest number coming from activity R and activity Q, and that is 42. So the total number of hours required for this project is 51. Now we are going to go back to determine the latest starting time. Notice that for activities N, M, and O, we need to take the smallest latest starting time from activities P and Q, and that is 31. We have just found the first activity that has a float time of 10. That is 29 minus 19. We have just found another activity that has a float time of 10, and that is activity I, with a float time 22 minus 12, which is 10. Notice that for activities F and J, we need to take the smallest latest starting time from activities M and K, and that is 18. We have found another activity, activity G, which has a float time of 10, 16 minus 6. So the answer we are after is option D, because we found 3 activities with a float time of 10. From the 2019 VCE examination report, only 31% of the students chose the correct option.